we're going to go ahead and take a look at long division today. So these are your notes that you should go ahead already have a copy of. We're going to go ahead and fill them out. So the bell ringer today was to go ahead and practice long division. That this is a topic you should have learned in elementary school. I say should, as we all know, things happen. Just as a review. So my divisor is what we're dividing by. So that's 16. We have 786. So we're going to go ahead and take a look here, and we see that I know for a fact that 16 doesn't go into 78, but we do know that it goes in 4 times because 16 times 4 is 64. So we subtract that value and get 14. We're going to bring down the 6. And now we're going to say, how many times does 16 go into 146? Well, it goes in 9 times. 9 times 16 is 144. And we subtract it, we have a remainder of 2. So in this set, and one of the things that we're going to be looking at is making sure that we're leaving a remainder in our answer instead of actually borrowing, because we're not going to borrow when we're elevating it to algebra 2 topics. So if you want to pause the video, try number 2, and then we can check your answer. All right, so let's go ahead and check your work for number 2. My divisor is 6. My divided is 876. 6 goes into 8 once. Subtract 6. Bring down the 7. 6 goes into 27 4 times. Subtract 24. Remainder 3. Bring down the 6. 6 goes into 36 6 times. Subtract 36. And we have a remainder of 0. So we have 2 different types of answers. Those with remainders and those without. But we're going to go ahead and just start our polynomial division. So polynomial division, we're just dividing by polynomials. We're going to start off nicely. We're going to start off dividing by a monomial. So remember, monomial means one term. So we are going to go ahead and divide by one term, and I'm actually going to switch the we do and you do. So we're going to go ahead and take a look at this one. If you have your notes, this is question 4. So we take a look here. When we do this, when divide by a monomial, it's really nice that we're just going to break it up into 3 separate fractions, because each term becomes its own fraction. We keep our sign. And so we're going to deal with each fraction separately on its own, and we're going to do like with like. And so what we mean by like with like is that we want to go ahead and do our numbers, our coefficients together. We want to do the A terms together, and we want to do the B terms together. So we can only do, when we're simplifying polynomials like this, we can only do like with like. So 21 divided by 7 is 3. A to the 5th divided by A. So remember, we have those invisible 1 exponents. And that quotient property says that when you have x to the m over x to the n, we are going to subtract the bottom from the top. So we're going to do 5 minus 1 and get 4. We're going to do, and then do the same thing for b. 3 minus 1 is 2. So it's 21 a to the 5th b cubed divided by 7ab is the same thing as 3a to the 4th b squared. And we're just going to follow that through for the rest of the problem. So we're going to keep our minus sign. 14 divided by 7 is 2. So again, we have those invisible 1s that we didn't see. 3 minus 1 is 2, so we get a squared. 2 minus 1 is 1. We don't typically write this one, so we're just going to have minus 2a squared b plus 63 over 7 is 9. 2 minus 1 is 1, so we have a. And then we get b to the 0. But we do have a property that says anything to the 0 power equals 1. Or also when we worked with fractions, you'd be like, oh, it's the same top and bottom. You cross it out. It becomes a 1 when we do that. So it doesn't really change anything. So our final answer is 3a to the 4th b squared minus 2a squared b plus 9a. So I want you to go ahead and try the previous question if you have it. I will put it up on the board or on the screen. Maybe. So I want you to go ahead and try that we do specifically. Or if you have a paper, you can go ahead and write it on your paper. let's go ahead and check your work. So we're just going to go ahead and just basically just do 3x squared, 3x squared. So 6 divided by 3 is 2. 4 minus 2 is 2. Keep the minus. 15 divided by 3 is 5. 3 minus 2 is 1. 3x squared divided by 3x squared, well, that is itself, so I get 1. So hopefully you had that correct. If not, again, reach out and ask questions. But we're going to go ahead and move on to long division. We're going to divide by a binomial specifically. And this first couple of problems that we look at are going to have no remainder, meaning that at the end I should have a 0 at the bottom, not a number or anything else. And just to review some division steps that we have, what's missing, this isn't going to come into play until we get to the latter half of the lesson. And it's just saying what term is missing. But as of right now, we're not going to worry about that. That's going to be done for us. Step 2 is we're going to divide, then multiply, subtract, bring down, and we are going to repeat. And when we say repeat, we're going to go ahead and repeat the list starting at question 2 and move on as we go through it. For step 2. So if you're following along in your notes that you have a copy of, this is actually question number 7. So if you want to keep it, if you want to take a look at that, that's where it is. So if you have the notes from me and I printed them out for you, you should notice that you have much more space, especially since we are doing long division, that you have space to do long division as well as show our in-between steps. So we're going to start off by go ahead and setting up. We're going to go ahead and put our divisor on the outside and our divided on the inside. So there is nothing missing, so I'm not worried about that. But we're going to start with step 2, which is divide. So when we say divide, we're always going to take, remember, divisor, we're always dividing by something on the outside. So we're always dividing, in this case, by 2n when we do our side work. And then as we go through this, we are going to try to eliminate the leftmost term. So we're going to divide by the leftmost term that we have, which in this case is 2n cubed. So we're going to take 2n cubed and divide it by 2n. So this is the same as if I had asked you, how many times does 2n go into 2n cubed? Well, my answer would be it goes in n squared times. So it's the same thing as when we ask you that, we're actually asking you to divide. So we're going to go ahead and make n squared our multiplier. So remember when we did that long division back for the elementary level question, that whatever we put up on the top, we then used to multiply the side. So we're going to multiply 2n plus 3 by n squared. So again, we're going to go ahead and distribute that n squared to both terms. And when we do that, we will get 2n cubed plus 3n squared. So that is my multiply step. And when we get that, we go ahead and subtract that value from the previous term. One thing I make the suggestion is that you can go ahead and apply the negative by flipping all the signs, so that when we do the subtraction, it's easier, because the further away you get from the word subtract, the more likely you're forgetting that you're subtracting. So 2n cubed minus 2n cubed cancels out. And then 3n squared minus 3n squared is going to cancel out. So we actually have a 0 here, which is perfectly fine. There's nothing wrong with that. But step 5 says to bring down, So we're going to go ahead and bring down both the negative 16n and the minus 24. Excuse me. I'm bringing down both terms because I'm divided by a binomial, so I want 2 terms there for when I do my subtraction. So in this case, instead of bringing down 1, we're going to bring down 2 items. And from there, we're going to repeat. So we're going to go back to dividing. So now we're going to take a look at this first term here, negative 16n. And again, we're going to still use that 2n as our divider. So how many times does 2n go into negative 16n? Well, it goes in negative 8 times. So that is my new multiplier. So I go ahead and put that on the top. And I already know one of the biggest questions we have is, why do I have such a big gap? When I work out my problems, I line up the the exponents are the type of problem. So I would put my constant over the constant, my quadratic over a quadratic, because I should only multiply by that type once. I should not multiply yet again by another constant number or another n squared number. That way it's like, oh, I messed up somewhere if I have to do that. But that is my multiplier. So we're going to head and multiply -8 by 2n plus 3 and get -16n minus 24. So we shall subtract that. And when we do that, we do get 0, which would make sense because I did tell you that we have no remainders for this first portion. So at this point, I am done. And the only thing I'm going to add is that this top portion is called the quotient. And that's very important that when you're actually working, they're like, hey, what is the quotient? They're just asking for what was up on top. So the quotient for this problem is n squared minus 8. But I just need you to be aware of this vocabulary term because sometimes it will pop up when the question they ask you to do something and you're like, what is that? But again, take a moment, pause the video, record, copy down what you need to, and then we'll go ahead and take a look at question number 6. So let's go take a look at question 6. So we have w squared minus 7w plus 10 over w minus 5. So my divider is w minus 5. My divided is w squared minus 7w plus 10. So one suggestion I do have sometimes is how do you get the line to be the correct length? Write the inside first, then draw your line or your division symbol. That may make it a little bit easier. But nothing's missing, so we're going to head start on step 2, which says we're going to divide. So we're always going to be dividing by w in this step. For this first one, we're going to divide w squared. So we're going to write w squared over w. This is invisible 1. 2 minus 1 is 1. So w is my multiplier. So we're going to take this w specifically. This is where that's w, and multiply my divisor by w minus 5. So again, this is coming. Let's do a different color. This part here is where this part's coming from. This w is coming from this w here. So we're going to head and multiply. When we multiply that, we are going to get w squared minus 5w. And again, we are subtracting. In division, we subtract. But because we have an expression instead of just numbers now, I do make the suggestion, apply that negative and flip all the signs so that you know that you are going to be subtracting, because it's harder for me to say -7 minus -5. You guys are more used to saying -7 plus 5. But anyways, our w squareds are going to cancel out. -7w plus 5w is -2w. Now we bring down the plus 10. So in this case, I bring down only one term because I have one term. I kind of want to match the number of terms I have with the number of terms we're dividing by. So I want 2 and 2. Oops. We'll do it this way so I have a bit more control over it. All right, so then now we're just going to repeat. So we take this -2w and divide it by w. So -2w divided by w. The w's would cancel each other out, and we're left with -2. So -2 is my multiplier. So we're going to do -2 times w minus 5, and we will get -2w plus 10. So if I go in and flip all the signs, it becomes a plus, this becomes a plus, this becomes a minus. -2w plus 2w, cancel out. 10 minus 10, cancel out, so I'm left with 0. So my answer is w minus 2. Again, as always, pause the video if you need time. But let's go ahead and take a look at the next problem. So this time we have r cubed minus 4r squared minus 26r minus 15 divided by r plus 3. Our divisor is r plus 3. Our divided is r cubed minus 4r squared minus 26r minus 15. So we're going to go ahead and do our steps. So if you would like, one thing I would like you guys to go ahead and do is pause the video, try it on your own, check and see. But let's go ahead and take a look. So on this one, I would do r cubed divided by r and get r squared. And then do r squared times r plus 3. So my multiplier is r squared. When we do r squared times r plus 3, we get r cubed plus 3r squared. Flip our signs, and our cubes cancel out, and we get negative 7r squared because negative 4 minus 3. Bring down the 26r. And now we're going to repeat. So we have negative 7r squared. And again, we're always dividing by r when in the step, so dividing by r. And we're going to get negative 7r. So negative 7r is my new multiplier. So we're going to do negative 7r times r plus 3. When we do negative 7r times r plus 3, we get negative 7r squared minus 21r. That I was supposed to do that a different color, but it's fine. So let's go ahead, flip the sign. So this becomes a plus, plus, plus. 7r squareds cancel out. Negative 27r, negative 26r plus 21r is negative 5r. We're going to bring down the minus 15. So now we're going to go ahead and do negative 5r. Negative 5r over r, and we get negative 5, which is now our new multiplier. So when we multiply r plus 3 times negative 5, we are going to get negative 5r minus 15. So another thing, whenever you subtract something from itself, so if I did 1 minus 1, 2 minus 2, 5x minus 5x, doesn't matter. If you subtract something itself from itself, you get 0. So my remainder is 0. So here is my answer, r squared minus 7r minus 5. For those of you who have a printout of the notes, you go ahead, try doing question numbers 8 and 9. And then you can come back and check your work. If you don't, we're just going to go ahead and go through those. So looking at number 8. For number 8, we're going to go ahead and set this up. Again, if you have, I want you to go ahead and try this. If not, and then check your work.
This is the end of your lunch.
So again, try this out and then go ahead and come check your work. Because the only way to get better is if you actually try it yourself. And you might notice that I actually start showing less and less work because we're going to be doing the same things. So again, when the question's missed, how much work do we show? You show your extra steps until you're like, oh, I can just do it now. So again, we're going to do x cubed divided by x and get x squared. And we're going to multiply our divider by x squared. And we would get x cubed plus 9x squared. Yeah. And when we do that, we get 0. So this time, because it disappeared, we're going to bring down 2 of them. We're going to bring down both the negative 4x and the 36. So now we do negative 4x divided by x then we get -4. So we're going to do -4 times x plus 9. So -4 times x is -4x. -4 times 9 is -36. And these all cancel out. So our final answer, again, in this case, is going to be x squared minus 4. Pause the video if needed. Pause the video if you don't have this in front of you. I want you to go ahead and try this problem. If you already did it, go ahead and pay attention. So it's going to set up.
Penny, it's for the lunch at this time.
So we're going to go ahead, take our first term, 4h squared divided by h, and we get 4h. So we're going to multiply by 4h. So 4h, again, what we're going to do is 4h times h minus 2. And we get 4h squared minus 8h. I got like 2 minus plus -7 plus a is +1. Bring down the -2. So now we do h divided by h and get 1. So we're going to do a +1. Make sure you always have a operation sign between your terms on the quotient. So again, make sure you have that +1 in there. Not just 1, but it is a +1. And 1 times anything is itself, is the item itself. So we're going to get minus h minus 2, which gives me a remainder of 0. So our final answer is 4h plus 1. All right, so moving on, so we have our next one. This is where we're going to start actually having remainders. And there's nothing wrong with a remainder. Remainder is perfectly fine. The only difference is more of how we actually write the answer. So here's a worked out example where they do the whole work. And a reminder, we said earlier that this top part is called the quotient. In this example, we have a remainder of 4. There's nothing wrong with that. When we do the remainder, the only thing that changes is how we write our answer. We're going to go ahead and do plus the remainder divided by our divisor. So we're going to do 4. In this case, it was 4 over x minus 2. The only other thing that might change had been if this had been your remainder is -4, we would have done -4 over x minus 2. This example is not on your notes. It is just an example, just kind of to show you it's already worked out. It's also something you can come back to look at if you have a couple more questions on it, like what did we do? And if you remember, I said I would go ahead and switch my signs. The red operations are them switching their signs to say, oh, I actually want to do this. So they're distributing the negative. There's no longer a typo on that handout. So here we have take a look here. We should have a remainder. So the setup and our steps are the same. The only thing that's going to change is how we write our final answer. So I do want you to go ahead and try it out and see what you do and see what you get and see if your stuff matches mine. All right, so we're going to do k cubed over k to get k squared. So we're going to do k squared times k minus 1. So we're going to get k cubed minus k squared. I'm going to flip my signs. And we end up, our k cubes cancel out. -8 plus 1 is going to be -7k squared. Bring down the -3k. So now we do -7k squared over k. We get -7k. So our new multiplier is -7k times k minus 1. So -7k And we're going to get negative 7k squared plus 7k. It is a plus because, again, when you multiply this through, we have two negative signs. Two negatives make it positive. So plus, plus, minus. 7k squareds cancel out. Negative 3 minus 7 is going to be negative 10k. Bring down the plus 8. So now we're going to do negative 10k divided by k, and we get negative 10. So we're going to multiply by negative 10. So minus negative 10k. Negative 10 times negative 1 is positive 10. So our negative 10k's cancel out. Again, we're going to switch these signs. My bad. 8 minus 10 is negative 2. So notice this time we no longer have a 0 as a remainder. So we're going to keep our quotient. And our answer is going to be k squared minus 7k minus 10. And in this case, because it's a negative, minus 2 over k minus 1. So again, this here is my quotient. And then my remainder, we have a remainder of negative 2. So actually, if I wrote that up here. So we have remainder negative 2. Hopefully, again, if you're doing these practice problems yourselves, it should be getting easier and easier because we are just going ahead and doing the same steps over and over. So I want you to pause the video, go ahead and try this problem. Okay, so our divider is n minus 5. We are dividing 6n cubed minus 20n squared minus 42n minus 47. So we're going to do 6n cubed divided by n, and we get 6n squared. So again, we're going to do 6n squared times n minus 5. And we're going to get 6n cubed minus 30n squared. And again, we are subtracting that. So let's go ahead, flip our sign. So this becomes a plus, minus plus. N cubes cancel out. Negative 20 plus 30 is positive 10. So positive 10n squared. Bring down the minus 42n. So now we do 10n squared divided by n, and we get 10n. So positive 10n is my multiplier. So 10n times n minus 5 would be 10n squared minus 50n. And again, we are subtracting this. So let's flip our signs. The n squareds cancel out. Negative 42 plus 50 is positive 8, so positive 8n. Bring down the minus 47. So now we do 8n over n, which is 8. So positive 8. So we're going to do 8 times n minus 5. And we get 8n minus 40. We are subtracting that. So let's switch our signs. Plus, minus, plus. 8n's cancel out. Negative 47 plus 40 is negative 7. So I have a remainder of negative 7. So our actual answer is going to be 6n squared plus 10n plus 8 minus 7 over n minus 5. Take your time to pause the video, copy what you need. We're going to go ahead and move on. So if you're in your notes, this would be question number 12. out of 16, so we are almost done. We are sitting the end of the light. So just go ahead and check your work. So we have 3a cubed minus 7a squared minus 30a minus 21. 3a goes into 3a cubed a squared times. So we're going to subtract 3a cubed plus 2a squared. Flip my signs. A cubes cancel out. We get negative 9a squared. Bring down the minus 30a. 3a goes into negative 9a squared. Negative 3a times. So again, that would be negative 9a squared divided by 3a. Previously, we had 3a cubed divided by 3a. Those a's, so again, a squared. So when we multiply that, we get negative 9a squared. Negative 3 times positive 2 is negative 6. We have to flip our signs. A squareds cancel out. Negative 30a plus 6a is negative 24a. Bring down the minus 21. Negative 24a divided by 3a equals negative 8. So minus 8. When we multiply by negative 8, we get negative 24a. Negative 8 times positive 2 is negative 16. I'm going to go flip our signs. Plus, plus, plus. 24a's cancel out. Negative 26 plus 16 is negative 5. So I have a remainder of negative 5. So our final answer is a squared minus 3a minus 8 minus 5 over 3a plus 2. And I've just come to the realization that all these problems had a negative remainder. Didn't notice that before. And so we do need that minus sign, but if it's a positive remainder, we just go ahead and do a plus sign. Pause the video as needed. But we are going to move on to now to where we actually need to use that first step that I gave you. We're going to do with a missing power. A missing power is just saying that we do not have a full countdown of our exponents. So we're looking at the exponents. So this is k cubed, this is k to the first, and believe it or not, this is really k to the 0, but that 0 is only attached to the k, so that k becomes a 1, and it goes away. So when we're looking at this and we say missing powers, I should have a countdown 3, 1, 0. I'm missing a 2 in the middle. So as you can see on our note here, use a 0 as the coefficient when there is a missing power in the divided. I can't divide in. Love proper terminology here. So we are actually missing a k squared. So we're missing a 0k squared. So when we're writing this out, we're going to go ahead, have k minus 3. And we're going to do k cubed. And since I have a missing one, we're going to do plus 0k squared. Because if I add 0k squared, it doesn't actually change anything. Because when you add 0, you added nothing. And now we're just going to proceed like normal, meaning that I'm just going to follow my same steps that we had earlier that are written right here. Rewrite what's missing, and then there is that. I think I changed it here. We had that division. I did change this PowerPoint to include that division part. And we're just going to redo those steps all over again. All right, so let's go ahead and just start with, let's do some purple. So we're going to do k cubed over k, and we get k squared. So now we're going to multiply by k squared, and we get k cubed minus 3k squared. Go in, flip your signs. A cubes cancel out. 0 plus 3 is 3, so 3k squared. Bring down the minus 9k. And we're going to do 3k squared divided by k. It's equal to k squared. This equals 3k. So we're going to do plus 3k and multiply by 3k. So we get 3k squared minus 3 times 3 is minus 9k. And let's go ahead, flip our signs. Plus, minus, plus. Cancels out. Bring down the minus 2. This is because of 0. There is nothing I can multiply k by to get negative 2. So this is actually my remainder. So we have a remainder of negative 2. Another negative. Crazy. Who would have thought? So our final answer is going to be k squared plus 3k minus 2 over k minus 3. Moving on again. Oh, there's always pause the video if needed. So I want you to pause this time and try this problem and come back and check your work. All right, let's go ahead and check our work. My countdown, I have 4, 3, 1, 0. So I'm again missing our quadratic term. So we're missing 0a squared. So again, our quadratic term is what's missing. So when we write this out, we're going to do a plus 8. And I'm going to divide a to the 4th, 8a cubed plus 0a squared minus 3a minus 16. So again, here is my placeholder. Now I will say sometimes your placeholder, you can get away with not putting it, but half the time, most of the time, you can't. And this is mostly good practice for later on for what we'll do in our next topic. So we have a to the 4th divided by a. That gets us a cubed. So checking your work, you should have multiplied by a cubed and gotten a to the 4th plus 8a cubed. So switching our signs, plus, minus, minus, cancels out, and we have a 0. So this is one of the few times, and I mean few times, that when I bring down this 0a squared, nothing's going to happen. It's a 0. So in this case, I'm going to bring down everything else. So 3a minus 16, minus 3a. So essentially, these right here, they just cancel out. I'm not even worried about them. I am going to look at negative 3a. So we're going to do negative 3a squared, or not squared, just negative 3a divided by a, and we get negative 3. So my new multiplier is negative 3. So negative 3a, and then negative 3 times 8 is negative 24. So we're going to go flip our signs, plus, plus, plus. 3a's cancel out. Negative 16 plus 24 is positive 8. We finally have a remainder that is positive. So our final answer is going to be a cubed minus 3 plus 8 over a plus 8. Now, if you actually did the extra step and you have an invisible plus 0a in there, you could possibly have that. That is fine. But we're not going to worry about that as much. Here's how it's supposed to be rewritten. Again, final answer. Pause the video, try this problem out. This is number 15 on your notes, if you have a copy of them. All right, so when we take a look at this, I can see I have 4, 2, 1, 0. So I'm missing 0a cubed. So we're going to do a plus 2. Hopefully that was long enough. 3a to the fourth plus 0a squared, or not squared, cubed, our cubic term, minus 20a squared minus 6a plus 14. Oh, yeah, just the right length. All right, so we're going to take that first term, 3a to the fourth, divided by a, and we get 3a cubed. Kind of hoping for a lot of things to cancel out. 3a cubed. When we multiply by 3a cubed, we get 3a to the fourth plus 6a squared, or a cubed. Flip our signs. A to the fourth cancel out. 0 minus 6 is negative 6a cubed. Bring down the minus 20a squared. So now we do negative 6a cubed divided by a, negative 6a squared. So minus 6a squared. So when we multiply that, we get negative 6a cubed. Negative 6 times positive 2 is minus 12a squared. Flip our signs. A cubes cancel out. Negative 20 plus 12 is negative 8a squared. Bring down the minus 6a. Negative 8a squared divided by a gets us negative 8a. So when we multiply by that, we get negative 8a squared. Negative 8 times 2 is negative 16. Our signs, plus, plus, plus. A squareds cancel out. And we get 10a. Bring down the plus 14. And we do 10a divided by a equals 10. So we're going to do a plus 10. So minus 10a. 10 times 2 is 20 plus 20. Change signs, plus, minus, minus. 14 minus, the a's cancel out. 14 minus 20 is negative 6. So I have a remainder of negative 6. And I'm running out of space. I'm going to write our final answer. So in this case, I'm going to write it as minus 6 over a plus 2 right here. As always, pause as needed to copy it down. And there's our answer. And for our last question, we have 36w cubed minus 27w squared minus 6 divided by 4w minus 3. Go ahead and try this problem. All right, coming to go ahead and check it out. I have 3, 2, 0, so we are missing a 0w. So my divider is 4w minus 3 dividing 36w cubed minus 27w squared plus 0w minus 6. So we're going to go ahead and start this. 36w cubed divided by 4w gets me 9w squared. So we're going to multiply by 9w squared. 9 times 4 is 36. W cubed, 2 plus 1. 9 times 4 is 27. When it's a negative 27, it's even better. On w squared. So we're going to flip our signs, minus, plus. Our w cubes cancel out, our w squareds cancel out. That's even better. 0 plus 0w minus 6. And this is my remainder. So this is actually really nice. So our final answer is 9w squared minus 6 over 4w minus 3. Such a nice one. So that is actually the end of our notes. And all I have to click through left is, yes, very nicely. That is the end of the lesson. So hopefully that helps you out. If you have any questions, do let me know, and I will see you in class again. Have a nice day.